We have Aaron Ploetz on the phone. I think many of you know he is the host of Cassandra Corner podcast, which if you don't listen to it, please do. It's all about the world of Cassandra. And he's a longtime Cassandra user. He's going to walk us through the new features in the forthcoming 5.0 release today. I think you might have seen, if you're on the dev list or user list, there's an alpha preview out for 5.0 now. Really cool new features like vector search that make Cassandra well equipped to support AI. So a lot of great AI conversations we'll have at Cassandra Summit, and many other features that will really expand Cassandra capabilities for a lot of different use cases. With that, get us excited about 5.0, and we'll turn it over to you.
All right. So, yeah, we want to talk about new features of Apache Cassandra 5.0, which is super exciting. This has been kind of in the works for a little bit here. And if you're a user of maybe something like AstroDB, you might have used a few of these features already, but it's super cool that they're getting retroed into Apache Cassandra. So let's kind of go over those. Again, here's a list of them, and this is just some of them. There are so many CEPs that have made it in, but we're going to be going through. We'll be talking about ACID transactions and storage attached indexes. That's another important one. As well as vector search. That is probably one of the more popular ones in terms of what's been going on lately with just kind of what's out there in the Cassandra community or database community at large. We also have like try-index memtables as well as try-indexed SS tables. We're just going to cover the memtables for today. And then, of course, transactional cluster metadata, we're going to talk a little bit about, too, because that one is like super duper important. Anyone who's ever managed a large cluster, you're going to love transactional cluster metadata. I guarantee it. So, hey, a little about me. I've been in the Cassandra community for a while. I started with, version 0.8 out in production at Granger. We had a 10 node cluster out there, but it was, So that's where I kind of learned everything here. A few years after that, I was the NoSQL engineering lead for Target. When I started there, we had maybe 24 clusters and a couple hundred nodes. And when I left in 2021, there were more than 200 clusters and about 11,000 nodes. And in fact, today I know the last time I checked with my old team, that node count is up to I think it's like 14,000. So Target has quite the footprint. I actually have contributed to Cassandra, although not in a really long time. But there were a few things that annoyed me about CQL shell that I wrote patches for back that made it into Cassandra 3. So it's been a little bit. I'm one of the organizers for the Minneapolis St. Paul Cassandra meetup group. And I've also done a little writing in the Cassandra space. The 3.0 version of mastering Apache Cassandra is mine. Actually, I was the lead author on that. I suppose worth mentioning now I'm a developer advocate for DataStax. So there we go. All right. Might as well talk about the one that's gotten probably the most press so far is ACID transactions, which are now coming in, Cassandra 5. Let's see here. Oh, yeah. So the driving force behind ACID transactions is the Accord protocol. There's actually a paper on it that kind of describes that protocol in great detail. But the idea is that we have a leaderless timestamp kind of strategy around how transactions are proposed and committed. So every node has this new structure now called a reorder buffer. And essentially what it is that it allows a fast path electorate if you have like a quorum of electorate nodes that agree to the transaction. It'll go ahead and be committed and allow it to complete in one round trip. I have the usually there on the one round trip because, well, usually they will agree, but there'll be times that I'm sure that they won't, which again is why we have ACID in the first place. But the idea again with ACID transactions is that with Accord, it's leaderless, so it scales a lot like Cassandra as well. And its failure modes also kind of match, Cassandra's own little failure nodes modes that it has as well. So it makes it for a pretty good fit. The idea is that, we all know what a coordinator node is, or, most of us do, I'm sure. But essentially, when a query can't go to a specific partition, it'll pick a node to be a coordinator. That coordinator is going to look at the transaction that is being proposed, and it's going to say, okay, well, here's a future timestamp that we could do this transaction at. And it proposes that timestamp out to the voting replicas, or this is the electorate that we were talking about just a moment ago. And as long as we get a quorum of accepts from those replicas, that transaction will then be completed and written out. So this is what the fast path is. So of course, if we have a fast path, I don't know if we want to call it that, but we also have a slow path. This is for if we have those times when the replicas don't agree, like they don't get a quorum of accept. So it'll respond back with the conflicting operations, and essentially propose a new timestamp to the coordinator, and it'll kind of start that process over again, where the coordinator will then repropose that new timestamp, and hopefully get everything resolved. All right, moving on. Storage attached indexes. Not a lot of folks talking about this one, but this one is this is a change that's central for a lot of other changes that we're going to see in Cassandra 5. Specifically vector search. But essentially what storage attached indexes does, this is like the next iteration of making secondary indexing in Cassandra better. So it essentially allows, if you have multiple indexes on the same table, it allows them to share data, which is pretty cool, and it actually keeps that index data footprint a lot lower. And likewise, it's it's what we consider the backbone for vector search as well, which we'll talk about a little bit. So similar to some of the other indexes we have, these are attached to their SS table. They also allow optional case sensitivity and Unicode normalization as well, and tokenization, which is another big one too. And the cool thing is that when building like the query path, they are row aware. So we are talking about a fair amount of query performance approval here if we're using using a secondary index. Here's a layout that's actually, or an image that's actually from the CEP out there that just basically shows some testing comparisons done with a billion rows, building out 1 to 10 indexes, using the legacy secondary indexes, SASE indexes, as well as storage attached indexes, and you can see the storage footprint for SAI is significantly lower than the ones that we already have out there. All right, the other cool thing about storage attached indexes, designed to leverage zero copy streaming. Zero copy streaming is a new streaming paradigm that was introduced in Cassandra 4. The basic idea is it gets us around, when we have like new nodes joining, or we have something else that like triggers a stream, so that we're not like reading from disk and then doing the serialization process and then sending that data over, because that takes a bit. This way, instead of actually serializing the data, we can move files, themselves over to the other nodes. Well, the files that back SAI indexes can now take advantage of that. So that's going to be significant as well, especially for writes and whenever you have to update those index files as well. And then hey, future features not coming in V1, but if you read through the CEP, you can see that in the future we're going to look at implementing things like and or queries, which again is something that we haven't been able to do in Cassandra before. Well, I guess you can do like now, but this is a definite improvement over what we have right now. All right, that's a good intro into vector search. So I'm sure that folks have been hearing a lot about this, because there's a lot of talk out there right now about vector search and what it does, what it brings to the table, what you can do with it. As far as, using Cassandra as like a backend for, AI ML based workloads, essentially, CEP30 implements an approximate nearest neighbor search in Cassandra, and again, using that storage attached index or SAI. This also brings in a new CQL type, which is vector, and it right now supports embeddings of type float32. So typically, when you'd create a new table, I should say, with a vector in it, you specify the type, which would be float in this case, and then the number of dimensions that are a part of that vector. And this allows for the approximation algorithms of you can do something that's cosine based or dot product or Euclidean. There are times when you might want to choose one over the other. I actually kind of found out the hard way trying to help someone out on Stack Overflow as to why a vector of all zeros was throwing an error. And it was because the index was cosine based. Switch it to Euclidean, hey, and it's fine. But with cosine based, well, then if your vector's all zeros, then it tries to divide by zero. And well, we all know that only Chuck Norris can divide by zero. So that's that. So for those of you who haven't maybe done a lot of vector search or maybe used a lot of it, essentially what it does is it is often used as like the storage or the embeddings are created by like the result of an LLM pipeline. So in this case, we could do like a product search. If we tokenize the product names of like love my dog ring chew toy or love my dog tennis ball toy, and we went ahead and did a like a cosine based comparison on those, we'd be able to tell, if we did a range of like, give me the, for an ANN, give me the, 5 or 6 closest to a particular vector. So we can determine, kind of where those data points are in vector space. And it's a way to get that approximation on data where you don't necessarily need to be exact. And like I said, I mentioned it about, using as like a similarity search for products, for maybe like a recommendation engine. You could derive it off of a lot of different things. But again, for recommendations, it doesn't need to be exact. You just need to be able to recommend something sort of similar. So in this case, it could be, hey, if somebody takes the Love My Dog ring chew toy and puts it in their shopping cart, we can recommend the tennis ball toy because that's kind of similar. And in this case, this is using a cosine based approach to that. All right. Hey, the implementation level for vector search. Essentially, I mentioned that vector is a new type, that you can create a new column type. Essentially, you specify the type here of float. Making this a 32-dimensional float was probably a poor choice in retrospect. As I look at this, I can see how that could be confusing. But that, you can create, really whatever size vector you need there. If you're implementing with, like OpenAI, I think, their most common, like LLM API, it comes back with 1,536 dimensions. So in this case, if you're going to support that, it'd be vector float 1536. Some of the other ones, like there's a specific algorithm whose name is escaping me right now that's out on Hugging Face that I've used before, which uses, I think, 384 dimensions. So this is, again, where you'd kind of specify that in the product vector or vector type definition, I should say, to kind of account and match up for that. And then, of course, you're also going to want to use that. You create a custom index on that vector column. And this is where we're using that storage attached index that we actually just talked about with a prior CEP. It also brings about, a new CQL keyword. So we have this, this ANN of here. So in this case, the product names of some of our shirts that we, all this data is a part of our e-commerce workshop, which, if you've seen it before, we have a few episodes of that out on the DataStax developers channel on YouTube. But essentially, these embeddings were built, using like the bag of words approach, where you kind of read through all the product names once just to like build your vocabulary, and it's laid out linearly kind of in a matrix, and each row has a either a 1 or a 0 depending on whether or not it has that word. Oh, Jeremy, that's a great question. Is the SEI index still going to require custom index? I thought I read that too, but yeah, I think I grabbed, I wanted to make sure I was grabbing working code, and that's what works right now, actually, out in Astra. But yeah, that's a good point as to I'm not quite sure what the future is going to be for that. Yeah, anyway, so in this case, this is what, how you do a vector query in CQL. And it brings it back, kind of listing out the vectors as well as some of the other data. Oh, that's okay, Jeremy. I get distracted by plenty, All right. So also worth noting about vector search is there's been some discussion on bringing in JVector as a dependency to kind of anchor that implementation. Trying to get away from the Lucene HNSW. Essentially, using JVector instead is going to give us a disk-aware approach that allows us to run, allows us to use it concurrently. I think right now HNSW is single-threaded, so that does kind of present a little bit of a challenge with, some higher throughput levels. But if you want to check out JVector, Jonathan Ellis actually has it out on his personal GitHub, so feel free to go to that URL and take a look at it as well. Couple of ideas behind this one. This is Branimir's, and I think Branimir's been on here before, doing a specific talk just about try-index memtables. He had a great presentation on this back at ApacheCon. Oh wow, that actually was a year ago now. Yeah, okay. But anyway, so the idea behind it is actually there's a few, but improving garbage collection around memtables is one of them for sure. This implementation also helps us reduce the memory required to host our like existing memtables that come through. Ultimately increases write throughput as well, because we've got the dual write path that kind of comes through, and when you do a write, it's got to go to the memtable, and it's also got to go to the commit log. Well, this kind of improves that throughput as well. And ultimately, when these things get flushed onto disk, it improves compaction efficiency because we're really, kind of cutting down on the amount of disk required as well. Yep, results in more compact storage. And this is the other cool part about it is that memtables can now reside off heap if we want to. And those that are on the Java heap are actually, they're actually a little more GC friendly when that time comes around. And this all results in faster lookups, faster reads, faster writes, faster memtable reads. So ultimately, this is going to be really good for us. And kind of the other thing worth mentioning too is that this is made possible by CEP11, which exposes that memtable API so that now we can have memtable implementations be pluggable. I mean, so in theory, you could write your own if you really, really wanted to, but this is going to allow us a few more options as far as being able to make more efficient use out of our RAM on each Cassandra node. All right, transactional cluster metadata. This is a big one. Again, going back to the last ApacheCon, Alex Petrov talked about this, and essentially what transactional cluster metadata is it introduces that cluster metadata, this new cluster metadata service. And the idea is that's what helps pass around things like table schema and token ownership so that we don't really have to depend on gossip for that anymore. I mean, gossip was great. It worked fine until you got into a really, really big cluster, and then, it was quite possible to run into some issues on that. I can tell you that in my days at Target, whenever we had to do a table change or anything like that, especially on a large cluster, and by large, targets cluster implementations in prod range anywhere from like 24 all the way up to 204 nodes in some cases. And when you're changing a table, those schema changes have to make their way out to every single node. And when they don't, I'm sure a lot of folks are familiar with this output of node tool describe cluster, is where you get a schema disagreement. Sometimes eventually it would work itself out if you gave it enough time. But unfortunately, most of us here know, I'm sure, that if it doesn't resolve itself, really the only way to move forward is to do a rolling bounce of the cluster. And that's not fun for anyone. So transactional cluster metadata is actually a big helpful change that that'll make a lot of operations folks happy. So again, we're talking about eliminating availability issues related to schema changes, and again, that is that's huge. And the other part of it too is that it improves that reliability of token ownership changes. So again, to go back to my Target example, actually, this time of year, they and all the other online retailers start gearing up for the holiday season. They're putting in things like code freezes and whatever on the application side, but on the infrastructure side, they're computing out and, making some projections about what type of throughput, how much throughput they're going to see from a lot of these clusters. And this is where they're expanding out. Because, I can tell you a lot of times in the holiday season, there are Cassandra clusters that would see 10 times their normal amount of traffic. So we're building out and expanding clusters in preparation for something like that. And when you do that a lot, when you build it out, I should say not only when you build it out, but also when you contract. Once January rolls around and you're paying a lot of money for cloud instances that you're not really using fully, and you want to retract some of those and come back, having that reliability around token ownership changes is huge, and it prevents a lot of operational headaches. So yeah, again, this whole thing with I'm going to disagree with gossip has worked. Well, it works enough. How about that? But anyway, transactional cluster metadata is huge. All right. Getting on to some of the other new features that we have here as well. For Cassandra 5, G1GC is a new default. If you've been in the community for a while and maybe you're on the dev mailing list, this discussion has come up a lot of hey, should we change the default garbage collection strategy that's used with Cassandra 5, or that's used with Cassandra, I should say. And the argument has always been, well, the idea is that if somebody fires it up on their new brings it down on their laptop just to try it out, G1GC is not really good if you have a limited amount of resources on a single node. So if you're running it on your own laptop, running G1GC on a 4 gig or lower heap, that's probably not a great idea. And that's why, for smaller clusters, CMS was still, probably a better option, in terms of throughput, if you knew how to tune everything correctly. However, CMS-GC is deprecated, and as far as I know, I can't remember which version of Java it was removed from, but I'm pretty sure it's not there anymore. So G1GC is new default. Yeah, Jeremy, you're right. It's one of those two. I was trying to remember which one, but anyway, I digress. Oh, right, and that was in response to Sarvanan. Anyway, but hey, this is great because again, with a newer version of Cassandra, hopefully we're getting more and more people off of Java 8. So that would be great. But G1GC is a new default, and of course, as I think Jeremy mentioned in the comments, that going with a newer JDK does also open up some of the availability of some of the newer garbage collection algorithms as well, like ZGC and Shenandoah. Definitely something worth checking out. And if I recall, I think Jonathan wrote an article on comparing one or both of those, and this has got to be a year or more ago, but I know it's out there. Yeah. Okay. Hey, an initial new feature is that an operator can disable. It's a little guardrail that's in Cassandra 5 is that operators can disable the use of simple strategy. Um, as a as a former operator in a large cluster environment, I kind of like this one because when you give a new cluster to a team, and maybe they don't know a lot about Cassandra. I hope as an organization that you're doing some education there and kind of helping those folks out. But what we've seen is that there will be teams that have built up their own cluster, maybe on their own laptop, or maybe they'd go and provision their own instances or whatever. Well, they do it with simple strategy. Then when they move up to an environment that's multi-DC, all of a sudden simple strategy isn't the best choice anymore. So disabling that and kind of forcing those teams, to build out as they're going, to basically build their dev and test environments like they would build production. And honestly, I think that's a good plan because that again gets them used to saying, oh, hey, we have to specify our default local data center, as a part of our connection properties. Whereas again, if you have simple strategy, you don't really need to do that. So it's kind of forcing folks who develop with Cassandra to think about those things a little earlier. And to be honest, if I had this option at Target, I so would have used it. Anyway, dynamic data masking. This one is more about if you're querying or pulling back sensitive data that you can set it up so that things can be like masked or obscured from the select. And I think it's based on what your role is, if I remember correctly. But so that's a simple one about that. Unified compaction strategy. This one's kind of big. We've been using this for a while out in AstraDB. Again, kind of with kind of around making Cassandra a little easier to use, and especially when you have a large enterprise, you have a lot of dev teams. Maybe they don't use Cassandra a lot. Maybe it's only for like part of their their application footprint. But the idea is that to have them pick a compaction strategy while building out their tables, while not really fully understanding the implications of it. Sometimes that can prove, problematic. The default for years has been that size tiered compaction strategy, which it has been really good. And size tiered is really good for write throughput, which originally is what Cassandra was, designed to be super good at. And then of course, leveled came around in terms of being able to support at least 90% of all reads from a single SS table file. And then we've had evolutions between like date tiered and time window compaction strategy. But the thing is that unified simplifies a lot of that, and is definitely a it's kind of a best of all worlds type of approach to compacting data on disk. So anyway. All right. So, hey, if you want to check out Cassandra 5, watch the mailing list. I don't think it's in alpha, and not all of the features are in it just yet. But if you want to check it out, I think where I found the download link is Mick made a post a while back about its release, and I think that's the only place you could really get the download link if you wanted to check it out. But otherwise, keep a close eye on, cassandra.apache.org. I think once we hit beta is when it ends up on the site, if I remember right. So I think that's all I've got pretty much here.
I think you had a favorite feature too. Did you talk about the TCM, right? For the reasons you mentioned.
Yeah, so mine is definitely the my new favorite feature is definitely the transactional cluster metadata. Yeah. Again, I think about all the times that, in a large cluster environment in the years past that I've been bitten by doing a table change. And we've tried to plan those at off times just in case we had to bounce the entire cluster. And yeah, this should alleviate a lot of that pain. Yeah.
So that is it. Really appreciate everybody joining, and we will see you again in a month. Thanks, everybody.
Hey, thanks, everyone.